people join. Hey, welcome everyone to our SUI Move Deep dive of the webinar. This is the part two. My name is Sandesh. I'm a senior Web3 developer here at Alchemy, and I'll be walking you through the blockchain and smart contract side of things. And with me, we have Darshan as well.
Hi, I am Darshan, working as a backend developer at Alchemy. We'll be covering the backend integration.
Yes. So before we do a deep dive, I want to say that we are absolutely thrilled to have 1,100 participants joining us for the final round of this hackathon. So this is going to be an amazing event, and we can't wait to see what you all build. So as a quick note as well, so please join our Discord channel if you guys haven't already. So throughout the hackathon, both Darshan and I will be there to help you guys out on any queries or any issues which you guys may have or face. So we will be there to support you guys. And also we have sent out Google Forms for all the winners of the weekly puzzles as well. So, and for those who have completed the 5 commits, so you guys need to submit that Google form, right? So to join the Discord channel. Now, for today's session is designed to be more of a practical walkthrough. So we're not here to give you theory or anything. So we are here to show you production ready design patterns that we use in real applications. So
And
let's dive in.
and from my side, we are going to like beyond the basic queries, we'll be covering production grade backend patterns, how to handle throughput, uh, manage a state synchronization, and error handling, and many more.
Yes. So before we start, I think we can wait for a couple of minutes to let others join as well. Okay, so let's get started. So welcome back to those who have attended our first hackathon session as well. So there we have covered the basics of SUI's object model there as well. So today we are going to do a bit of deep dive into the architectural decisions and production patterns as well. So as a quick recap for those who weren't there, so uh, we'll give you a brief introduction of SUI as well and what are the advantages. And the previous webinar's link will also be there mentioned in the description below. So you guys can check it out to get the basics and what all we have already discussed. Right. So today we'll focusing on how and when. So how to choose between object types, when to use shared objects versus owned objects, and the real performance implications of these decisions in production systems as well. Right. So as the session overview, we'll be having object models in SUI. We will also be going through Node backend integration, how we can use the SUI TypeScript SDK to make smart contract calls from the backend, how we can listen to events, how we can even store them in the database and everything. Right? After that, we'll be having a problem solving session. So we'll teach you guys how to actually implement these things which we have learned. So it'll be a practical application based round. Then at the last, we'll open it up for Q&A for all the questions which you guys might have. So let's get started. So object models in SUI ecosystem, right? So understanding SUI's object model is very important because in SUI everything works on objects. So SUI is an object-centric data model, right? So as in Ethereum, if we know that everything works on account based, so everything is linked to a particular account. But when we talk about SUI, everything is a particular object ID. Everything is an object that is underlying linked to your account. So you will be the owner of that object. So there are multiple types. There are mainly three types of object models as well in SUI that we will cover here. And the first one is owned objects. We have shared objects as well and immutable objects. So we will be going through what each of these are and what is the importance of each of these. So the first one is owned objects. Owned objects are single address. So these are particularly tied to one account itself, one owner. So these type of models are the most commonly used and the most recommended as well to use. So now, as we can see in the code block here mentioned as well. So notice we have here the key ability. That is what it makes an object, and also we have store ability that allows it to be transferred. So when we call, as you can see on the last slide here, just one sec. Okay, yeah. So as you can see here at the last, we have mentioned the transfer that has an extension of transfer, and we have the sort context and the senders, right? So what this transfer keyword means is that it is an owned object, right? Only specified recipient can use this word, right? So this is the basic meaning of it. No one else will be able to use it. Next, we have the shared objects as well. So objects that are accessible by anyone. So multiple transactions can read and write them, but they require consensus. So as we can see in the example below as well, so a game board, right? So it has a key. That means it is stored as an object on chain. When we are creating the object, as we can see at the last line, there is a transfer share object. So when we use the share object extension here, it means that it is an shared object. We are storing it as a shared object. So that means there is no particular owner. Anyone can use it to call the functions. Right? And the last one is immutable objects. So what does immutable objects actually mean? So once created, these cannot be modified. These are perfect for values such as NFT metadata, certificates, or permanent records because these are some things which we do not want to change ever. Mm. So what is you may ask, what is the advantage of these as well? Right? So the major advantage is maximum parallelism. Since they can't be changed, there's no contention. So this is one of the major things why we recommend using owned objects or either go for immutable objects. Shared objects is a very good feature, but we need to make sure we use it only when and where necessary.
Yeah, when it
Next,
comes
we
to the
also
immutable object, oh, yeah,
yeah,
when it comes
Darshan,
to
go
the
on.
immutable object, if you are integrating with a backend side, the its state won't change. So we can cache those values or we can store those values and reuse. We don't need to make multiple network calls.
Yes, that is very true, Darshan. So because the value will never change, we can just cache it rather than
Yeah,
making multiple calls every time we need the value. So that is a very good point. Next, we have permission patterns as we have. So what are permission patterns? So these are basically your access control. In Web 2, Darshan would handle this in a middleware like database permissions, But in Web3, when we do it, we encode permissions directly in the smart contract. So let me show you guys. So as you can see here in the code, we have a admin cap that has a key and a store, and it will have a ID. So what does this mean? So this means that this admin cap will be stored on chain and it will be linked to a particular user. So as we can see here in the code example below as well, there is a treasury as well, okay, which will have a certain amount of balance similar to a bank. Okay, and we have a withdraw function where, as we can see, it takes the admin cap as a parameter, but it's only used as an underscore. So what does this actually mean? This means that that value is not actually being used, but we are just checking that the one who's making the call, okay, or signing the transaction, does he actually own that admin cap? Does he have the ownership to provide for it? Right? So if he has it, then this function will execute. If not, the function will reject it directly there itself. That is what we mean when we define capability patterns or admin cap. Okay. So no cap means no withdrawal. It's as simple as that.
Yeah, from an
Next,
integration
we
standpoint, yeah,
yeah, that
from
should
an
go on.
integration stand, like when it comes to the backend side, we need to manage those capabilities objects. Like um, we track capability ownership in our database and only allow operations if the user has the required cap in their wallet address.
Yes, that is very true. So that wallet should have the permissions or should be the owner of that capability. If he
Yes.
doesn't have it, then he cannot do anything with it. Right? So next, we also have the witness patterns. Okay, so what does this witness pattern actually mean? So whenever we deploy a contract, we have a init function. So this is the function where we initialize the contract, initialize most of the structs, initialize most of the object IDs itself. So what actually happens is when we run a init function, we need to have a witness. Why is this important? Is because this function needs to run only once and should not run any other time. So we add a temporary witness there so that it will run only once. That is the main reason why a witness is actually required. Once the contract is deployed, there is no witness for it. That means the init function cannot be called again. Right? So next we also have the transfer mechanism. So let's say we have a admin capability or any in-game item as well. So if we need to transfer it to someone as well, so we need to have that capabilities for it. So that is also very much important. So let's go through this code as well. So as we can see here, we have a struct of item which has a key and store. So as previously mentioned, so key is the ability that we actually use so that we can store it on chain as an object, and store is used so that we can transfer it to other wallets or people as well. So main thing is one, we have a direct transfer. So here what we do is we transfer the object directly to a new recipient. That means a new wallet. Second is transfer using reference. That means we keep the object itself, but we transfer the reference to that other person. And third is we have a public transfer. So public transfer, what happens is we transfer the object entirely to that recipient along with the IDs and everything. Right? So these are three of the transfer mechanisms which are very common in Move, and these are some of the things which you guys will be actually using as well. So next we have a share object and freeze object as well. So I think as we had discussed, share object is basically used for sharing an object, right? So multiple people can use it and call it, whereas a freeze object is nothing but an immutable object. So We cannot change it or make any difference to it. So it is immutable in state.
So it's like defining a constant.
Yes, absolutely. So it is like defining a constant in your code. So you can't make any changes to it. So next we also have dynamic fields as well. So dynamic fields are nothing but extended objects in a contract. So whenever we need to make any change to a particular value, right? So we need to update it dynamically rather than redeploying a contract to change that value. We have something known as dynamic fields. We can change the values from there, right? So it adds an extension to change as well. So as we can see here in the below mentioned example as well, so we have an inventory struct and an item struct, right? So we can add an item as well, and we can even remove an item. So this is directly making change to that object rather than deploying a new contract. It's just making changes directly just by calling functions. So that is where this dynamic fields comes into play. Next, we'll be going through how you can even integrate a smart contract with backend, how you can call smart contracts from backend, even listen to events, which is very much important as well, and how you can even store it and use it. So, Darshan, over to you now.
Yeah, thank you. So you may have question like why we need a backend to integrate with a contract itself. Because suppose we need to show some graph or some analytics purpose, or we need a UI for interacting with the contract. In that case, we need a some backend or some code needs to interact with the contract level. For that, SUI come up with their own SDK package. It contains everything. We can directly interact with the contract, and we can do the transactions, and we can listen the events, and we can trace that what exactly happening on the contract side. So this is the first command to install the packages, the machine SUI packages. And in the next, you can able to see here we are importing the SUI client and full node URL and transactions from the package. And in the client here, we are initializing the new client with a testnet. See, this get full node URL, we are initializing with a testnet. But the SUI will provide three different networks, the devnet, testnet, and mainnet. When we are working with the production level, we have to go with a mainnet. And suppose if you are doing some development purpose, in that case, we can go with a devnet. While we are testing those smart contract and integration, everything, we will go with a testnet. So suppose if you want to read some object from the contract side, uh, you will already know that what is a object and the different type of objects. So in this first code snippet, uh, we are from the client we are calling the get object. So this get object is inbuilt function by the SUI SDK itself, and we are passing the object ID, and as an option we are like these are the boolean parameters: the show content and show owner, show type. So show content is nothing but we are passing as true because we want to show, like we want to get those data. The show content will get the whatever the data present in that object, those data will be present. In the show owner means uh, it will give the owner address, owner wallet address, and show type will be the object type. The object type may be a coin type, coin, or a NFT, or the custom defined object. So it will show the type of that object. And next one is get object by type. So in this case, what we are doing is we are passing the owner wallet address and the object type. So we are calling the get owned objects, and we are passing this a contact the owner wallet address. In the filter side, we are adding the struct type is object type. So this struct type is nothing but a usually we will define a class, right? So but in the move side we will define it as a struct. So you can imagine that it's a class or some uh, it's a class, and for each functionality we will create like new class. So here we are passing that the type of struct. We need to set a struct name, and here also we are passing as a options the show content and show type is true. So it will, if you passing the true, it will return all those information, otherwise it will ignore it. Like we can set this a false also if you don't want to read those value. In this case it will return all the objects owned by the that wallet address and which belongs to that particular struct. Coming to the third one, the dynamic fields. As early Sandesh mentioned, the dynamic fields, how it work, like the structure, everything. Here, this is the code snippet, how we can read the dynamic fields. So here we are taking as a parent ID. Can you move to next slide? Yeah. So here we are using the get dynamic fields and we are passing as a parent ID. So in this case, it will take the parent ID or the object ID and it will fetch the all related objects and the
And
data.
the
Uh, uh, Next one is read game data, read game board state. So in this case, we are again calling the board ID and the option the show content is true. So uh, here it will show the related data that belongs to that particular object. And here we are verifying that the content is data type is move object or not in this case. And we are returning those values also. Uh, yeah. So here it comes the how like we saw that how we can read the data from the contract side. So in this step we can able to see the how we can initiate the transaction from the code the TypeScript SDK to contract side. So just think about like we have the forward as a uh, public function defined in the smart contract. If you want to execute that function in the from the uh, TypeScript SDK or from the backend side, first we need to initialize the key pair. So here we are using the private key. While coming to the production, we have to make sure that private keys needs to be very secure. Otherwise, we will like it will cost a lot of things.
that is very true, Darshan. We need to make sure that the private key is kept very secured.
Yeah, maybe a secure vault or some physical key like driver to inject those values whenever it's required like that. So in this function, we are passing the package ID and recipient address and strength. So this new transaction again we are initializing the new transactions here, and next step you can able to see the tx.move call. Here we are defining what needs to be done. The target is the package ID, and this game defines the move module name, and this forge sword is a function name which we are going to call. And in the arguments we are passing a strength, but this is bit different from how we will handle it in normal typically like web 2 the web 2 code. Because see here you can able to see that tx.pure.u64, basically the strength is defined as a number, but when it comes to the contract side there is multiple numbers. Like it depends on the how we have defined based on the requirement. Maybe a U8 or U16, U32 or U64. In this case we are using the U64, which means the number length will be in that the number should be in that particular range. So when we want bigger number range we will go with higher, so maybe u 128 something like that. It will keep on like increase. It depends on the again the requirement. And suppose if you want to send in an argument. If you want to send as a object, you have to use tx dot object. And again, when it comes to the address, if you are passing it as a address, tx dot pure address, and in the the bracket, we have to pass that address. So we have to make sure that the whatever the data type we have defined in the contract, that should match with this or whatever we are going to call here. Otherwise, it will throw the error. And uh, just a second. So just a second. Go back. Can you go back to the no, back? Yeah. So next step is sign and execute. So up till now, like we just created the transactions and we are ready to call the SUI contract. So we will provide the sign and execute transaction. In this sign and execute transaction, we already we have taken the key pairs and we are ready with the transaction also. And we have added that show effects as true and show object changes as true also. Here, what will happen is once the call is happened like to the contract level, it will show the effects. So what are the object got changed and what exactly happened, and what are the, suppose if we have deleted some object in this particular function, or if we updated, or if we created new object, so those information will be available in this particular result. We have saw that the single object modification. Now the next one is the update shared object, that is defined as the update game score. Yeah. So here, what we are doing is, again, we are building the initializing the new transaction, and you can see here the target type. In the target, we set the package ID, and game is some move module name, and update score is a function name which we are going to call. In this here, see, last time we have used tx.pure u64, and here also we have used the same thing. But here one more thing you can able to see the tx.object, the board ID we are passing. This is a shared object reference. So this is the difference. Like with
Yes.
that each data type, yeah,
Yeah. No, that is very true, Darshan. Yeah.
we have to make sure like the data type should match whenever we are calling the contract side. And next step we are signing the transaction and executing that. So you may like ask like why we need to sign and execute, because when it comes to the blockchain, we need a signature for each and every transactions. We need to know like who executed those transactions. Otherwise it will be like we can't do the transaction itself. It won't allow those.
Yes, those are very true. So we actually need to store those off chain as well for a record and to access it whenever we need it as well. So that is
Yeah.
why we have a blend of Web 2 and Web 3.
Yes. Yeah.
Yeah.
So now here comes the event listening and processing part. So how we will get to know like suppose we done the transaction, but we will only get the object, whatever the object it got changed, the those information we will get. But how we will get know, like suppose if you want to get some other information, the custom information we need to emit. So here it comes the events. So here what we are doing is we are passing the package ID and the event type. So in the line the client dot query events, it will query those events with this custom filter. Like it will here we are passing the package ID and the event type. The event type may be any event. See in this sword forged, this is the one of the event we are like capturing in this particular example. uh, so it will listening that those events, it will capture those events, and we can do the we can query those events based on the limit also. There will be the like huge data on chain. We don't need to query at at a same time. in this case, we will add the event, the limit for each query, and the and we here we can add one more the cursor also to do a pagination fetching, and we can define the order also, the descending or the ascending order.
Yes. So as Darshan mentioned that we can also do pagination as well. So one of the major advantages of that as well is that we may have a lot of transactions. We may have hundreds of thousands of transactions on a contract as well, and every time we can't fetch each like every one of those. So we need to split the data into batches. So that is a very important functionality which the SUI SDK gives us out of the box itself. Right, Darshan?
Yeah. So we don't need to worry about like how we will handle those multiple, like lot of transactions, like, or thousands of events. We just need to like, we just need to set up the limit and the last cursor. So it will pick up the last sequence, and based on that sequence number, it will fetch from the like fetch ascending or descending the other events.
Yes, very true. So, and also on a part of that, whenever we need to listen for events on the contract, we need to also have an emit function, right? So,
Yeah,
events, all events should be emitted that we need to store off chain. Okay, so we cannot query for events for which there is no emit event. So, we won't get any data for it.
yeah. Here comes the crucial part, because we will end up with the errors. So how we will going to handle those error every time, like while we are working, the contract may throw error, or we may face network issue, or some other related other issues. So in that case, the in the best practice, what we can do is we can go with a retries. So this is the wrapper function. We can use those as a, like, while we are calling the transaction or we are doing the contract call, we can do like maximum 3 retries or 5 retries based on like some timeout basis. Because we may like, if you call frequently, we may end up with some other error. So we need to add some buffer time, or delay time before we are calling once more. Like, suppose we got a error first time, we can't call again like immediately. So we will add some delay between the like subsequent calls to get the proper result from the contract side.
Yes, absolutely. That is very much true. Like error handling is one of the basic and most important concepts as well.
Yeah. Suppose you can say like what will happen if it reaches the maximum retries. So we can set some alerts, or we can think about some handling those cases also.
Yes, absolutely. Because we do not want to miss any of the transactions as well,
Yeah,
right? So let's get on to the main part, like the problem solving part. This is where we will be giving you guys a walkthrough of what are the design patterns which you should follow, how you should approach a problem as well, for all of those who will be participating in the final round as well. So this will give you a brief idea of how to approach the problem, how to architecture your contract, and how to start solving. So the first is NFT marketplace with the royalties. So as you can see the problem statement, it states we need to create an NFT marketplace where creators receive 5% royalty on every secondary sale. So first of all, we need to think what all functionalities we will actually be needing, what all functionalities we will be needing, what all objects we will be needing to store as well. So if you see the contract, there are majorly two things. One is we need an NFT. Second, we need a listing place. We need a marketplace. Right? These are the two major things which we will actually be needing. So as you can see here, we have a public struct NFT, which has a key and a store. And we also have a listing, which has only a key because we will not be transferring it. So that's why we don't have the store capability there. Then, as we can see in the function as well, the list NFT function. Okay, so what actually happens here as well? So whenever a NFT is listed, okay, it creates a new listing. So store in NFT listing. Okay, and that NFT is actually listed in your listing struct. Then we also have a function to purchase a NFT as well. Right? So we need to add the listing object ID, then we need to add the payment, then the NFT ID, and the context. So what all of these mean is, so listing object ID is the object ID which we get when we deploy the contract. That is for that particular struct. Okay. Second is the payment. So this is the coin object ID. This is what we'll be using to actually make the payments. Third is the NFT object ID. Whenever we mint an NFT, okay, in Sui, it is generated with a particular object ID. So that is the ID which you need to have here. And context means it will take the details of the signer or the caller. So as we can see below as well, okay, first what we do is we calculate the royalty. How much royalty will he be actually getting? Then we also split the payments. Right? So how do we do it? We have a coin split functionality, okay, to actually split the token as well. Similarly, we also have a join functionality as well. So we will have it later on. Okay, then we transfer the payments. One is to the NFT creator who will actually get the royalty. Second is to the payment. So this is how we actually split the token and split the payments as well to each individuals. And lastly, we need to also transfer the NFT to the buyer. So what we do is this is an owned object. Right? So as we can see here, we transfer it as a transfer function, not a shared transfer, not a public transfer. Right? So because of this, the NFT is owned by that particular person. Next, we also have staking with reward distribution. So the problem statement is pretty straightforward. So users stake tokens and earn rewards proportional to their stake and duration. So uh, how can we actually go about with this problem? So first of all, you need to know some key concepts as well for this. The first one being, okay, so tracking stake amounts and timestamps. So how a staking actually works is it is very similar to FD, which you make. Okay, you stake your money for a particular amount of time. Okay, and for that particular amount of time, you get some rewards. So it's a very straightforward concept, but how do you structure it? Okay, that is the main part. So first of all, we need a pool for it. Okay, where people can actually come and stake their amount or tokens as well. Then we need a staking position because each and every individual person will stake a different amount, will have a different lock-in period. Right? So each of them will have a unique stake ID that will be unique only for them. So next we also have calculate rewards. So what happens in the calculate rewards is for the particular amount of time the user has staked, we calculate how much rewards he is actually eligible for. And that is the amount which we will actually be giving him. Okay. And the user will not be able to unstake before his lock-in period as well. So these are some of the basic functionalities. So based on these, we need to architecture what all functions we will actually be needing, what all object IDs we will also be needing, right? And for the next challenge, yes, the multi-signature wallet. So what this problem statement is, we need to create a wallet requiring m of n signatures for transactions. So let me give you a brief about what multi-sig wallets are. Okay, these are particular wallets which have multiple accounts tagged to it. So if you need to make a transaction, let's say there are three wallets tagged to it, okay, it will need at least two signatures to make that transaction. So there's a threshold limit set to it. So we will need at least two transactions or the majority of the transactions to execute it. It's not a single person transaction. So what are the key implementation points here? That we need to store proposal with signers list, track who has signed, and execute when threshold is reached. So we need to architecture it thinking what are the functionalities we need, what are the structs we will actually be needing, what object IDs we will be needing to store as well. So as we can see here, this is in a, we are calling the contract from the backend here.
Yeah,
Okay. So Darshan, if you can just explain this bit.
yeah, sure. So, as Sandesh mentioned, like we are going to like multi-signature ballot. So, in this case, at least suppose just think about three ballot we have configured. We need two valid signatures to perform this transaction. Otherwise, it will fail, or we can't perform those transactions. So, here what we are doing is uh, we are building the new transaction, and we are initializing a new transaction, and we are building that transactions with a serialization. And next we are calling, we are setting up that move call with the required things. The required means the as a object id we are passing the valid id, and the pure as a, it's an array of bytes, transaction bytes we are going to pass. So uh, actually in the move side, like it won't allow string directly, like it will take it as a array from array buffer kind of thing. So we need to pass it as bytes, transactions bytes. So that's why we are passing it as a tx pure array from bytes. And as a result, we are returning, like we are signing and executing the transaction. In the result we are getting the signer, uh, yeah, and signer and the transactions, those details. Yeah. So this is what the to approve those transaction, uh, we are building the transactions again, and we are setting up with a like with a approve call, and the argument as this is a pure object id, the proposed id we are going to pass here, uh, and again we are signing and executing this transaction with the that particular wallet address. So we have to be make sure that which client is going to sign and execute this transaction. We can't use same signer at multiple time. So that's why we have taken it as a function like params. So the signer will be different for each time that ed 25519 key pair will be changed. So which is nothing but it will contain a private and public key. Why? For that, who who is the user, like who is going to sign that particular transaction. Without the private key we can't sign the transaction. And if you go to the swiss scan, and if you click on the view the particular transaction, then you can able to see the signature for each transactions. So as an input, that is required like very much.
Yes, those are very true, Darshan. So this is how you can actually uh, make calls from the backend to the contract, how you can execute the transactions, how you use your signature as well.
Yeah,
So these are very important points and very useful as well. So next we have some of the most common pitfalls and what are the solutions for it as well. So the first one is object not found user. So this is the number one error in production. Your backend tries to use an object that doesn't exist or isn't owned by who you think it is owned, right? So it may be transferred to someone else as well. So what are the solutions for it? Always check owner object ownership and its existence before use. So use the get object as Darshan rightly mentioned. We have that in the SDK as well, right? So use it for proper error handling. So that is very much important. So next we also have the pitfall 2, which is shared object contention. So what does this actually mean? I mentioned earlier, like shared objects are bottlenecks. Like if multiple people try to use that same object, okay, then it will cause an error. Okay, so how do we actually manage it? That is one of the most important things. So design for parallel execution, that is one of the most important things. Use per user objects instead of single shared objects, as we mentioned earlier as well. So whenever designing a contract, shared objects seem a lot easier to implement, but owned objects perform a lot better. So that is one of the major uses of it.
Yeah,
Okay.
as
Next,
an
we also have,
example,
hmm,
uh,
yeah, Darshan.
yeah, for the shared object, like right, the per user objects, we can give the sui coin object as an example, because whenever we will transfer, they will create a new object ID instead of using the shared object.
Yes, that is a very good example. So as we know, like there are millions of transactions going on around at the same time, right? So how do they actually manage it? That was a very good example as well. So the next is gas estimation failures. Okay, so this is when we do a dry run. So Darshan, if you could take it up.
Yeah, sure. So before we are like calling the sign and transact execute the transaction, uh, we can get the we can go with the inbuilt function dry run transaction block. So it will do the uh, execute those transaction. It will check the estimated gas fee. Like as a result, we will get the dry run result. We will able to calculate the proper gas fee, gas amount, how much it is going to cost. The gas amount will be like, again, it depends on how much we are computation we are using, and the how much storage we are going to use, and other factors. So we will calculate that, if we got the transaction result, the gas estimation fee, while we are sending the we can set the gas budget while we are calling the transaction itself, then it won't fail. Like it's a like better way to write a code.
Yes, that is very true. It is like we have a check before we actually execute the
Yeah,
transactions.
yeah.
Yes, that
Before
is a
like
very good observation as well.
yes.
So next we have come to the end of it, and we will go over what are the main key takeaways from this webinar. So one is the object model best practices. Okay, use own objects for user specific data, that is for wallets or uh, any of the NFTs or any object IDs which you have. Okay, then use shared objects for collaborative state, for example game boards or pools. So there you need shared objects because multiple people will be using the same object ID. So that is a particular example. Then use immutable objects for permanent records, such as certificates or metadata. These are the type of data which you never want to change. Right? So it is as a const in Web 2, as Darshan rightly mentioned. And
Yeah,
next, we have implement capability patterns for access control. This is very important because you need some functions which only admin can call, which only users can call. So for this, you need to know how to maintain your capabilities and access control.
yeah.
Yeah.
When it comes to the backend integration tips, so suppose if you are like frequently calling some immutable object, you don't need to call, like we can store it and store it as and we can use those, like. So I know, like we can't use like we can't cache everything, but few objects whenever it's possible, we can cache those event or store somewhere in a DB or as a cache. We can reuse that and use event subscription for real-time updates. So this is what we have already discussed about the query events. Um, the Sui SDK will provide to query those events from the on-chain events, the live events. For the live events, we can do the long pooling, like frequent pooling with some set of like timeout. We can able to get the near to real-time events and implement a retry logic for network failure. Suppose if you are calling like multiple times, or we may reach out the uh, like as a rate limit, or we may like facing some bad network issues, or like it may fail also, like for other reasons also. So better to like use the retry logic with a like as a 3 or 5, whichever suits for like the design, uh, and use a batch read operation when possible. Like in this case we don't need to call multiple times the we don't need to call like if we able to read that multiple data from the contract at the same time, there will be the less failure case. Suppose if you are calling individual, uh, we, if you are calling 10 individual calls, we may get 5 only, like we may the failure case is high, like we don't need to go with that. So it's a single call we can get those events or the data uh, stored store derived or computed data off chain whenever it requires. Like suppose if you are designing some dashboard kind of thing or some UI for the end user, we can even query from the contract every time whenever it requires. But we don't need to do that, like there will be the failure case, or um, we have to keep on continuing like calling the chain or the events, query those events. So better to store and keep the required minimum data in your database, or uh, wherever you are, like how you are managing, better to keep it in a database. So future use we can use those data.
Yes, that is very true because, as we mentioned, for reference, we will need that data later on as well.
Yeah.
Next comes the performance optimization. So, first of all, we need to minimize the use of shared object usage to reduce contention, as I previously mentioned. So, majorly go for owned objects, as that is one of the best things to do here. Okay, but depending on your implementation or the requirement as well, shared objects will also be used. Then use dynamic fields for extensibility. So as I previously mentioned, whenever you need to change anything in an object, you can store it in a dynamic field. And so rather than redeploying the contract just to change some values, you can make it a dynamic field so you can change it along the way. So that
Yeah.
is a very useful functionality as well.
Yes.
Then we also
And
have batch transactions, right? So we can use batch transactions it is required. So
mm,
I think Darshan would be a good person to give more details on this.
yeah. So batch transaction whenever possible. Suppose we are going to like performing multiple transactions, but like all are independent. If it is able to like make it as a single transaction, like we can call it as a single, like at a time we can execute all those transactions. If it is not like involved with a shared object, only we are dealing with a owned object or immutable object. So this is the like better way to do those operations. And next one is the implement a cursor based pagination for large result sets. As we already discussed while we are uh, discussing about the query events, we can go with a cursor. So like mm, cursor means the pagination. Uh, so there will be the set of records at each query, like we will be able to fetch or process those transactions. We don't need to handle bulk data to process those. Yeah.
Yes, that is a very good point as well because we can't query the all the transactions in a single step, as we
Yeah.
previously discussed as well. So using pagination is very much important as well. So these are some of the key takeaways from this webinar. So let's open it up for Q&A, and we will also be having Tanya, who will be mediating the Q&A and reading the questions out for us as well. So guys, if you have any questions for us, so you can go ahead. Now's your chance.
Thank you, guys. It was a great session again, quite insightful. And we have gotten a couple of questions, but before that, let me just quickly introduce myself. I know you guys can't see me, but I am Tanya. I am the Web3 Marketing Manager at Alchemy, and I've been given this job to moderate the session. So I'll quickly pull up the questions that we had. One of the questions were around how would the judging criteria or the selection criteria, the evaluation criteria look like for the final problem statements. So if you guys can just talk more about it and let these guys know how will it look like.
Yes, absolutely. So that is actually a very good question as well, because for the judging criteria, right? So we will give you out problems, and we will be checking how good you are at practically implementing those, how good you are at structuring the contract, what is your approach to it, how are you actually architecturing the entire contract. So these are some of the things, and the other things are the completeness of your contract as well. How good are your test cases? Are your functionalities actually working? Right? Because writing a contract is one thing, but we also need to make sure that the functions are also working as well. So those are some of the main things as well. And all the contracts which you guys write, it has to have clean code as well. And you guys also need to deploy the contract and make a few transactions as well on the testnet to prove the validity that yes, your contract is working, and you have also made a few transactions to prove it as well.
Perfect. Thank you, Sandesh. And then there's one question from Hitakshi Arora. She was also one of the winners from the weekly puzzles. She's asking, can I host the submission?
By host, if you mean, can you make it as a public repository, Hitakshi?
I mean, that's the only comment that she has left, but if you can just, like shed more light on it.
Okay, yeah, because even we are not sure on what she means by host, but if she can, clarify on the question, we'd be happy to help out as well.
Okay, sure. Hitakshi, if you're still on the live session, which I'm hoping you are, can you please clarify on your question so that the guys can answer? Then we have one question from Zenonite. So in the final round, do we have to host the front end and back end on cloud or just provide code for local setup? I think this is a similar question on what
Yes,
Uh,
Hitakshi was asking.
yes, a similar question to what Hitakshi had mentioned. Yes. So when the front end and back end, you do not need to deploy it on any cloud or anything for displaying it to us. The only thing is you can run it locally. You need to push the code to a particular repository and share the link to us. And also you need to have a video walkthrough of it, a demo video as well, proving that yes, all the functions and everything is actually working. So along with it, as I mentioned, you need to share the package ID of the contract with a couple of transactions as well.
Perfect. And what are the submission criterias is what Akshat Tripathi is asking.
So yes, the submission criteria as we had previously mentioned as well, right? So first is the code completeness. Your code should be complete. That means all the functionality which we have provided to you, the challenge which we have provided, all end-to-end cases should be working, and it should be a working contract. Then you also need to provide a demo video of the walkthrough as well. You need to also provide the package IDs with a couple of transactions of it as well, and you also need to submit the code as well. The criteria will be based on how complete your code is, and how good or clean the code is actually written. What is the architecture which you have followed? Is it the best practice or not? So these will be some of the criterias on which we will be judging. And also, you need to write test cases to validate your contract as well. That is a very important thing.
Okay. I hope that clarifies Akshat's doubt. And then we have second question. By the way, being intuitive has been praising Darshan a lot. So the question from him is, how can we maintain state consistency between Move smart contracts and traditional backend database?
Yeah,
Yes. Yeah, Darshan, take it away.
yeah. Yeah, as we discussed that the query events, whenever we need to maintain those data in the backend or database side, so we will be using the query events with a long polling. So whenever the transactions is happen, we can able to query those events and we can process and store it in the database. We can do it in near real time basis because we need to do a polling. Uh, yeah.
Perfect. Thank you. And then there is another question. What will be the time duration to complete in the final round? I think this is one of the um, key announcements also of this particular session. So if any one of you guys can just pick it up.
Yes, absolutely. So the time duration will actually be 4 days for the hackathon. So you will be having a time of 4 days. So you need to complete everything within that time frame itself. Any submissions or anything after the time frame will not be considered.
Awesome. So as Sandesh has and Darshan has mentioned, the time duration that was given to you earlier, the deadline has been extended to one more day. So now the final prototype round will start tomorrow, which is 28th of November. And it was supposed to end on 30th of November, but it will end on 1st of December. So if you guys have any, if you guys need more time, you can just, you have this one more extra day to yourself. Another question that came up was, what about new ones who do not know blockchain but more efficient in burn stack and did many projects? Um, I mean, if you guys want to take that up.
Yes, absolutely. So if you guys are very new to blockchain as well, that is perfectly fine because this will give you a chance to actually get started with blockchain. So if you know MERN stack, you either know JavaScript or Java or any of the core languages. So with this, you can actually learn some basics of SUI as well because it is based on Rust. At the end of the day, it is still a programming language, so you can pick it up. If you have done multiple projects, it gives you an edge as well because you know how most of the components actually interact with each other. You can architecture it much better because you know how to build components, how to interact and how to connect each of those as well.
Right. And just to add to what Sandesh is saying, we are also trying to provide more and more resources for you guys to kind of learn about the Move programming language, and which is why we have our Discord channel where we keep sharing resources. We have also shared a sample problem statement for you guys. So if you are keen on understanding and preparing better for the final prototype round, you can check out the Discord channel and just go through the announcement that we have just shared. Another question is from Niranjan. He's asking, how do we handle event streaming with Move based blockchain?
Yes. So that's actually a pretty good question as well. So if we actually want to, handle the event stream, then we need to have a web socket set up for it. Okay. With that, we can actually stream what all events actually coming from the Move blockchain as well. But in most of the cases, even if you want to stream it, the better option would be to just use RPC call because streaming basically we need it when we have a very high volume of transactions as well. So based on that, it is always recommended go with an RPC call unless you have very high transaction count. But if you do, then you need to have a web socket set up for it.
All right. Thank you, guys. Just one last question that we'll take up because we are almost 1 hour into the session now. So, uh, Akshat has asked, is there any scope for the AI engineer with a basic knowledge of blockchain? If you guys can just quickly pick that up.
Yes, absolutely. There is a lot of scope as well for even if you have a basic knowledge of blockchain. So the main thing is, even if you have a basic knowledge, you can switch to Move and you can switch to Sui and learn about how it works, because as Ethereum, it has a lot of issues and is a bit complex to learn as well. But Move is pretty straightforward, so it'll be very easy for you guys to actually pick it up as well.
Awesome. Thank you, guys. Um, I think we've covered most of the questions. There is someone who's also asked if you guys can share the details about the judging criteria and the submission part on what you guys were sharing about. So, we will be sharing all of those details along with the final problem statement tomorrow. So, don't worry about it. You will get all of those details in the email. And even then, if you have any questions, you can join the Discord channel and you can ask any of your queries related to this particular hackathon, any problem statement, uh, anywhere that you get stuck. We will not be providing you end-to-end solution to these problem statements, but we can just try and guide you. The team is going to be available there, so don't worry about what exactly is going to be the submission. Like if you are confused somewhere, just go on to our Discord and then ask your queries. And I think that brings us to the end of the session. Thank you so much, everyone. This has been a wonderful session. We hope that all of you all participate, and this becomes like a um, good learning challenge for you all. So, Sandesh, Darshan, would you just like to say something, add something?
Yes, absolutely. So, as Tanya mentioned, so all of us will be available on Discord as well. So, in case you guys feel like you are getting stuck anywhere throughout the hackathon as well, so we will be available to guide you and point you towards the right direction as well. So, this will be a great opportunity as well to explore what Sui can actually do as well.
Yeah, apart from that, if you are not from the like a blockchain side, or you are part of some other AI or the front end or back end, you can start learning from the Moo and Rust Moo, and you can just like get into the Sui ecosystem. Like we are here to like help you whenever if you need any help from our side, like we are there.
Thank you both, and thank you everyone for staying with us throughout the session. All the best.